Let's take some notes! Alright, so Cramer's rule, another cool thing with determinants, or with matrices, we need to figure out a new thing with matrices called a determinant. The determinant of a 2 by 2 matrix is called a second order determinant. It is taken by changing the brackets into what looks like absolute values around the elements. That's telling you, what am I doing with this matrix? I'm taking the determinant, and you multiply diagonally A times D, and diagonally B times C, and you subtract the two things. So if we do that in our example, we multiply the 3 times the 5, and we subtract from that the multiplication of the 7 times -2, and then we simply simplify that to see what we get. So this becomes 15 plus 14 becomes our answer. The determinant of this matrix is 29. So then we move on to a 3 by 3 matrix. It's called a third order determinant. There's a couple of ways to find it. The way I like to find it is by expanding along the top row, multiplying each element of the top row by the determinants of the matrix formed by crossing out the elements in the row and column of the first row. So we're going to start by taking 4, and we're going to cross off the elements in that row and column. And we're going to take the determinant of what we have left. So the determinant of 2, 6, 5, 9. We then have to alternate signs, so we're going to subtract now, taking the middle element along the top row, crossing off that row and column, and taking the determinant of what we have left, -3, 6, -4, 9. And then we just did a minus, so we do a plus. We have a 3 times the determinant of what we get crossing off that row and column. -3, 2, -4, 5. Each one of these determinants we do with the diagonals. So, multiplying diagonally and subtracting on each one of those, we can then work out our determinant. So working that out, if we call this matrix A, then the determinant of A, using those absolute value bars to show that we're taking the determinant here of A, equals -93. So determinants, being able to take them means you open up a whole useful area of mathematics here. It's hugely useful in finding the area of a triangle in 2 space. The area of a triangle with 3 vertices, A, B, C, D, and E, F. We did this once last year in geometry, where you had to find the perpendicular, find the point where it intersects the opposite sides, so you can calculate the length of both the base and the height that form that right angle, so you can multiply by 1/2 the base times the height. It was a long problem. This shortened things up tremendously using this formula. The area is 1/2. You put each of the points in, A, B, C, D, E, F, and you put a row of 1s on the far side. So, a zoologist tagged one of the 3,200 wild tigers left in the world with a GPS tracker to determine the tiger's territory. After weeks of collecting data, she saw that the tiger's territory was a triangular region, with the vertices -2, 8, 4, 12, and 0, 0. What is the area of the tiger's territory? So we're looking for the area inside our 3 vertices, forming that triangular region that she found. We're just going to plug into the formula. -2, 8, 1, 4, 12, 1, 0, 0, 1. And now we're going to do our expansion. So as we go through finishing our determinant here, we get a nice -28. We want to know that it's an area, so area is never negative, it's positive. We have 28 units squared for our area. The book, I believe, defines this as A, and then says you have to take the absolute value of A for the area. So the technical definition takes care of the positive or negative thing. I've just always found it's more convenient when I'm doing this. I know I'm getting an area, so I know when at the end that if it's a negative, I make it into a positive. And that's what that part of the book's definition is trying to tell you. Alright. Which brings us to the ridiculously cool Cramer's Rule. Cramer's Rule is a way for solving systems of equations. So we're going to solve 5x minus 6y equals 15 and 3x plus 4y equals negative 29 with this Cramer's Rule, which says, okay, we're going to have a coefficient matrix. So you take the coefficients of the x, y's, and you make them into a matrix. Ching. Coefficient matrix. So if we do that down here, we have 5, negative 6, 3, 4. We're going to multiply our coefficient matrix by a column, x, y, and that has to equal our solution matrix. 15, negative 29, a constant matrix. So if we take the determinant of our C matrix is the coefficient matrix, and we take its determinant. We do the diagonals, so 5 times 4 is 20 minus negative 6 times 3 is negative 18, so 38 is our determinant of C. That's going to go on both our denominators here. To find x, we replace in the coefficient matrix the x's with the answers. So 15, negative 29, negative 6, 4. We're taking that determinant and dividing it by 38. So we have our x is the diagonals. 15 times 4 is 60 minus 6 times 29. 60 minus 174 then is negative 114 divided by the 38 gets us negative 3. When using Cramer's Rule, we're going to do y the same way, except we replace in the coefficient matrix the y's with the answer, so 15 and negative 29. Still dividing by the determinant of C. So we get our diagonals, 5 times 29 times negative 29, so negative 145 minus 3 times 15, which is 45, all over the 38. So y is negative 190 divided by 38. Which is negative 5. So our x, y solution to this is negative 3, negative 5. Dun dun dun! You can also do this with 3 variables and 3 equations. What? Oh, it's getting crazy up in here. So, finding all of these determinants takes meticulous care and effort. But let's do this. We're going to say, okay, we have a coefficient matrix of 4, 5, negative 6, 3, negative 2, 7, 7, negative 6, negative 8 times our x, y, z. and equals negative 14, 47, 15. Ooh, these are going to be fun fractioning answers, I can tell already. So here is our new C. The determinant of C is going to be, so you finish calculating the determinant of C, you get your 621. That's going to be your denominator for your X, your Y, and your Z. When you go to find your X, you replace the X column with the answer column. And then you take the determinant and you divide by the determinant of C. And surprisingly, we get X equals 5. So we just compute the determinant and find our Y equals negative 2. Very surprising we have whole numbers here. We only have to find Z. Z is the only one that's left. So we got a little space in our bottom corner to compute our Z. So run through your calculation. Make sure you get the same thing. Answer the question with your ordered triple. Our XYZ answer is 5, negative 2, 4. And we're done. So, calculators are useful. On your calculator, if you press the second key and then go down to matrix in blue, which is the X to the negative 1 button, you bring up your matrices options. If you go over to edit, you can input your matrices, hit enter on edit, then you have to put in your rows and columns so that it knows how big you want your matrix to be. And then you can simply hit in whatever matrix you want to hit in. When you quit and go back to the main screen, you can then again go second matrix, but this time go to math. Math gives you determinants, a T that we don't know yet, dimensions, fill, identity, random, augment, matrix lists, lots of cool stuff going on here. As you can see, if you scroll down, it's quite the long list of things that we can actually get here from the matrix, but the DET that is number 1 stands for determinant. DET, determinant. So if you put your matrices in, you can check your answers to make sure you actually took your determinants correctly. Once you hit enter on the determinant, you have to put a name in. So again, you have to put second matrix, and then you have to, in the names list, go down to the one you want to tell it which matrix to take the determinant of. Mwahaha!